Hello and welcome back to chemistry. This is Mrs. Schroeder and I have a guest with me today. This is
Lane Madison.
one of my former students, and you probably will know her. You've seen her in the hallway. We're going to talk today about specific heat. So Lane's going to help me teach you guys how to calculate specific heat and energy changes. The first thing we want to talk about is actually defining specific heat. Now, we talked about this in the first section. If you look in your books on page 45, you could find the definition. Do you see it there, Lane?
No. Oh, okay. The quantity of heat required to raise a unit mass of homogeneous material, 1 Kelvin or 1 degree Celsius in a specific way, given constant pressure and volume.
Okay, great. So you can look that up in your textbooks and you can write that down. Now, in order to find out what specific heat is, we don't have to destroy material. We're actually going to do this in lab next week. So if we don't destroy it, that would mean that it would be which kind of property? Chemical property or physical property?
Physical.
Very good. Okay. When we start talking about energy, we're talking about how energy is transferred. There's some things we need to know. One thing is the nature of the material. That's what specific heat depends on, what kind of material you have. We also need to understand the mass of the material and the temperature change. And we can use this formula, Q equals mCp delta T. The little triangle here means delta. It means change in. So pause the video for a second. Write down what these mean, because you need to understand what all these symbols stand for, and especially what the units are. Joules, grams, joules per K. And temperature is a tricky one because it can be in K, which is Kelvin, or C, which is Celsius. And I'll show you in class how we do this, but when we talk about temperature change, we're always subtracting the final minus the initial, not the initial minus final. So we can end up with a negative temperature sometimes. So pause the video for a second, write down this information if you still need time. Okay, so some specific heat capacities are given in this table. And there's another table in your textbook on page 60. You can see that the heat capacities, water is a little higher than some of the other materials. Water's around a 4. Things like aluminum, iron are down below 1. So what does that mean to the material? If you have a high heat capacity, it means the substance takes more energy in. It makes a good insulator. So if we're developing a new material or developing a new use, we want to understand how much energy it takes to change temperature. A low heat capacity would make a good conductor. It means energy travels through it easily. So if I was trying to make a frying pan up, would I expect to have a material with a high heat capacity or a low heat capacity?
Oh, the pan would have a lower heat capacity because it's metal.
Okay, very good. And then when I'm trying to make a thermos, I'm obviously trying to insulate my material, and it looks like it's got metal on the outside, but if I actually look on the inside of a thermos, I see that there's some vacuum spaces, some air spaces, and some glass spaces. So with this material, glass and air, would that have a high heat capacity or a low heat capacity?
High.
Okay, very good, because you're trying to insulate things. Alright, so now we're going to take a look at how we actually use that equation. Q equals mCp delta T. Again, Q stands for heat or energy. So if I'm trying to find out how much energy, this is my Q. So what does Q equal? Start out by saying, what do I have? Can you find the mass in here?
Oh, 46 grams.
Okay, and then I need a specific heat, but I'm not given a specific heat. Often the book is going to give you problems like this where you are missing some material. But if you remember back a couple slides, I told you there's a table in your book back on page 60. So if I look on page 60 in our book, see if you can find your heat capacity for nickel.
0.444.
Okay, so sometimes I have to actually use that. And Appendix A is another good place to look in your book. It sometimes has things that you need. Okay, now again, my units are kind of strange. Joules per gram, degrees Celsius. And then when I'm looking at temperature change, my temperature change I said was T final minus T initial. My final temperature is the one I end with. What is the temperature that I end at?
56.3.
Okay, and the temperature I begin?
24.
Okay, so take a second and see if we can calculate what that would be. So 56.3 minus 24 degrees.
32.3.
Okay, so now I have my temperature that I'm going to put into my equation. And when I multiply 46 times 0.444 times 32.3, what do I come up with for Q?
659.6952.
Okay, and units are going to be joules. Now, we're in the significant figures chapter, so we have to round it off. Going back to our significant figures rules, I have 2 here, I have 3 here, and I have 3 here, which means I have to have 2 in my answer. So how would I report this correctly?
660.
Okay, 660 joules. Okay, and that would be how much energy is transferred. We're going to try one more problem here, and then I'll let you guys, we'll do more in class. So in this case, it's a little different. In this case, the student is heating up a material, and they're trying to find what the specific heat is, because again, specific heat is a physical property, which means that if I can find specific heat, I can figure out what this material is. So I'm going to use the same equation, Q equals M Cp delta T, but now I'm going to be solving for Cp. Okay, so first off, I need to look at my Q. Can I find Q somewhere?
253.1 joules.
Okay, mass?
23.62 grams.
Okay, Cp is what I'm trying to solve for, so I'm going to leave it this way. And then my temperature change, again, 36.79 minus 21.6.
It equals 15.19.
But again, since I'm looking at significant digits, I need to round this guy off to the ones place here. So, or the tens place. So I'm going to round this off to 15.2 degrees Celsius. Okay, now when I try to solve for Cp, I have Cp on this side, I need to get it by itself. So what do I have to do to these numbers to get Cp by itself?
You divide them out, right? Yeah. Okay, you divide them out.
So 253 divided by 23.62 divided by 15.2. Take a second and calculate that.
Okay, so the bottom is 359.024. So 0.686.
Okay, and again, correct significant digits is good because right here I'm left with 3 significant digits. So I should have 3 in my answer. Again, units are kind of strange. This was in joules, mass was in grams, and this was in degrees Celsius. So I have joules per gram, degrees Celsius. So specific heat can be used for a lot of things, calculating energy, calculating how much it'll change, or calculating what the specific heat is. I could actually go back to that table and find out what this material is if I can find something with that specific heat. And we'll let you try that on your own, see if you can match that up and figure out what the material is. So we will see you bright and early tomorrow morning. Bye.